should just make an assumption, but you cannot make an assumption without a query sheet. All right, thank you so much for understanding that. Okay, so before you take off, the first step that you do once you get to a taking off exam or assignment, when we are coming up with a bill of quantity, the first process is usually to measure. Taking off is just measuring. For example, we shall measure the areas of the walls. We shall measure the volumes of the concrete that we shall use. We shall measure the length of the reinforcements that we use. Why do we measure? Because when you come to the bill of quantities, I'm going to show you in a concurrent video what a bill of quantity is, and I'm going to take you through an example and how we fill it in. But in the meantime, you need to know that a bill of quantity usually have columns which describes the work, which gives us the measurement for the work. For example, an area of the wall, we could say it is 50 meters squared area of the wall. All right, so in the description you could be told it is 200 millimeters thick wall. Then in the measurements, now that which we shall take off, once you measure, for example, okay, what will determine whether we should measure the length of the wall or the area of the wall or the volume of the wall is called this method of measurement. Maybe you have heard of the SMM or the NRM2 or the ARM4. All these are the methods of measurements that guides us when we are doing measurements. The methods of measurements, it's just like a method of measurements is like a quantity surveyor's Bible. It gives us the guidelines on how we should measure. For example, different countries that have the same methods of measurements measure their walls in the same way. You see, the method of measurement guides every quantity surveyor how they should measure, the unit of measurement they should use. For example, if the SMM, the standard methods of measurement, right now we are using this SMM7. If the SMM7 tells us that areas walls should be measured in terms of area, then we shall know that in the bill of quantities, the unit for the wall should be in area. Now, if we have measured the area of the wall and we have realized our small building has 400 millimeters squared of the wall, how do we know the cost of the wall? That is where we come up with the unit rates. You see, in our videos, we have done quite a long playlist showing you how you come up with the unit rate. Now, in the unit rate, it will be telling us the cost per meter square of constructing the wall. In the unit rate, that's where we shall find what will be the cost of materials for building the wall, what will be the cost of labor, what will be the cost of the plant that we could be using. Okay, then we shall add the profits and the overheads. Then we shall calculate the cost per meter squared. Then, assuming that we had 200 meters squared of the wall, once we multiply by the cost of the wall per meter squared, assuming it's like 150, so we shall take 200 meters of wall, 200 meters squared of the wall is the wall. Okay, the building has 200 meters squared of the wall. Then we shall multiply by the cost per meter squared, like 150. Then we shall get the cost of the wall, right? Meter squared. Hi everyone, welcome back to our YouTube channel. My name is Naomi and I'm going to take you through taking off substructure works. In a previous video, I introduced to you how we do taking off for substructure works. We also have a couple of videos, both on PowerPoint and handwritten, that explains to you how we do taking off substructure works. We are so grateful that you're here, and in this channel, we help students understand bills of quantities, quantity surveying concepts, the whole process of coming up with bills of quantities and estimating, costing, building, and civil engineering works. So, in this channel, for all our new viewers, students ask for videos, then we do them for them. For example, there is a video that they asked for. Explain to us, like beginners, how to do taking off. We did one video and there are a couple of questions in that video. And in today's video, I'll be explaining taking off substructure works in the simplest way possible for a bit complicated building, a bit complex, because in the previous video we did a rectangle, but in today's video we will have a building that have voids. You see, I'll be explaining to you how voids are measured and how they affect taking off for building works. In the series of videos that you are going to do, we will be explaining to you the whole process of coming up with a bill of quantity, from the taking off, abstracting, and billing. And in this series, we are going to give you an example for everything that you're going to learn. So keep tuned. If you haven't subscribed to this channel, kindly subscribe right now, so that whenever we upload these types of videos, you can be notified. We are going to do videos for masonry walls, but we'll also do videos for cavity walls. So in the methods of measurements that you are going to use, you see, in this I could be saying some phrases that you could not be understanding. I am hoping to talk in the simplest way so that you can understand. Let me begin. Okay, when we are doing coming up with a bill of quantity, we usually measure the building works. For example, when we are constructing the foundation, you see, we usually do site clearance. We remove the vegetable soil after we remove, you see, after site clearance, we usually remove the vegetation from sites. Maybe there are trees growing, maybe there are shrubs, there are bushes. We usually uproot them and take them away from the site. So that process of clearing the site, maybe there were buildings that were there, we needed to demolish. That process of bringing everything that was on the site away from the site, that is the process that we call site clearance. In everything that you see, a bill of quantity usually quantifies. A bill of quantity usually tell us the cost of coming up with a building project. So everything that you're going to do in that project has a cost implication. For example, if we do site clearance, for example, cutting down trees, uprooting the shrubs, removing all the grass, all these things usually have a cost implication. We have to pay for them. So because in a building project, everything that we are going to do, we have to pay for it. That's why we usually estimate the cost of all these works that you are going to do, so that you can be able to know how much the project is gonna cost us. So when we are coming up with a bill of quantity, the first process is usually to measure. Taking off is just measuring. For example, we shall measure the areas of the walls. We shall measure the volumes of the concrete that we shall use. We shall measure the length of the reinforcements that we use. Why do we measure? Because when you come to the bill of quantities, I'm going to show you in a concurrent video what a bill of quantity is, and I'm going to take you through an example and how we fill it in. But in the meantime, you need to know that a bill of quantity usually have columns which describes the work, which gives us the measurement for the work. For example, an area of the wall, we could say it is 50 meters squared area of the wall. All right, so in the description you could be told it is 200 millimeters thick wall. Then in the measurements, now that which we shall take off, once you measure, for example, okay, what will determine whether we should measure the length of the wall or the area of the wall or the volume of the wall is called this method of measurement. Maybe you have heard of the SMM or the NRM2 or the ARM4. All these are the methods of measurements that guides us when we are doing measurements. The methods of measurements, it's just like a method of measurements is like a quantity surveyor's Bible. It gives us the guidelines on how we should measure. For example, different countries that have the same methods of measurements measure their walls in the same way. You see, the method of measurement guides every quantity surveyor how they should measure, the unit of measurement they should use. For example, if the SMM, the standard methods of measurement, right now we are using this SMM7. If the SMM7 tells us that areas walls should be measured in terms of area, then we shall know that in the bill of quantities, the unit for the wall should be in area. Now, if we have measured the area of the wall and we have realized our small building has 400 millimeters squared of the wall, how do we know the cost of the wall? That is where we come up with the unit rates. You see, in our videos, we have done quite a long playlist showing you how you come up with the unit rate. Now, in the unit rate, it will be telling us the cost per meter square of constructing the wall. In the unit rate, that's where we shall find what will be the cost of materials for building the wall, what will be the cost of labor, what will be the cost of the plants that we could be using. Okay, then we shall add the profits and the overheads. Then we shall calculate the cost per meter squared. Then, assuming that we had 200 meters squared of the wall, once we multiply by the cost of the wall per meter squared, assuming it's like 150, so we shall take 200 meters of wall, 200 meters squared of the wall is the wall. Okay, the building has 200 meters squared of the wall. Then we shall multiply by the cost per meter squared, like 150. Then we shall get the cost of the wall. Right? So if we have concrete now, how do we calculate the cost of concrete in the bill of quantities? We shall calculate the volume of concrete. The volume of concrete, we shall take the length times the width times the thickness of the concrete. We shall find the volume of the concrete. Then we shall go in module 3, in our next module, we shall calculate the cost of the per 1 meter cubed of concrete. So it shall be, we shall take the material cost, the labor cost, the laying cost, the machinery cost, plus profits and overheads of 1 meter cubed of concrete. So that one, it shall give us the total cost of the concrete. So that is just an overview of how we come up with the bill of quantities. So you understand why we need to measure. So when we are measuring, we need to know, first of all, how do we measure? Should it be in linear meters? Should it in square meters? Or should it be in cubic meters? Once we know that, then we shall go and we have said what guides us is the standard method of measurement, or the method of measurement in your country. Maybe you're using the SMM, maybe you're using the NRM2 or the AR4. The concept is the same, but the only difference is how you apply it, but the concept is the same. So that is why we need to take off. Takeoff is measuring. So in takeoff, we usually measure the lengths, the areas, the volumes, the numbers, and all these units are guided by the method of measurement. All right. So once you understand why we take off, because we take off so that we can measure in preparation for the bill of quantity, so that we can take the units of measurement, we multiply by the unit rate. You see, units. Unit is like per meter squared, per meter cubic, all right? Then we shall multiply by the unit rate to get the total cost. Now that you have understood why we take off, now we shall go to how do we take off. We have understood why we take off. Now we want to understand how we take off. All right. To understand how we take off. All right. Every time that you're given something to take off, you have to be given a drawing. Why do you need a drawing? Because taking off measurements, estimation and costing, coming up with a bill of quantity is work done by the quantity surveyor. They estimate the cost of that building, but they can only estimate the cost of the building once it is designed. You see, a bill of quantities is usually prepared before we start the construction process, so that we can be able to choose the most suitable tenderer, the best contractor according to the price quoted. All right. So the bill of quantity, because it is prepared before the building is constructed, we usually use the drawings to estimate the cost of the project. More to the drawing, we could have another document called the specification. The specification is a document that explains further details. If there were details that were not provided in the drawings, we usually have a specification document. It specifies very clearly all details that are not in the drawing. Maybe we could not be having the ratio of concrete in the slab indicated in the drawing. Then the specification will go into detail and explain to us the ratio of the concrete. What happens if we are not provided for some details in the drawings and they are not found in the specification. All right, that is a good question people were asking. So if you find that the drawing does not have some details that you need to take off, and also the specification document doesn't have these details, what are you going to do? There is what we come up with called a query sheet. All right, so a query sheet. I hope you can be able to see. A query sheet is that is the one that we shall come up with. What is a query sheet? In a query sheet, we usually have two columns. We do a question, and we have another column for the answer. Alright, so in a query sheet we shall have a question and an answer. A query sheet is usually prepared by a quantity surveyor asking the architect or the structural engineer to give them good details that are not present in the drawing or the specification. But now when you're in an exam or once you're given an assignment so that you can be able to do takeoff, and there are not these details, you don't have any architect to give you the details or a structural engineer. So it is you as a student to write your own question, then make your own assumption. All right, so a question could come in two ways. For example, we were not told the thickness of the wall. Maybe in this drawing we weren't told the thickness of this wall. Okay, even for now I have not indicated it. So if we are not told the thickness of the wall, we could ask a question: what is the thickness of the wall? All right, we could ask what is the thickness of the wall for a question. Then in the answer we could answer the thickness of the wall is to 25 millimeters thick. All right, so question: what is the thickness of the wall? Answer: the thickness of the wall is 225 millimeters thick. Another way you can bring out the question: is the thickness of the wall 225 millimeters thick? Then the answer will be yes. So you can ask the questions in two ways. You could ask an open-ended question like what is the thickness of the wall? Then the answer could be the thickness of the wall is 200 millimeters thick. Or you could ask a question whose answer will be a yes, like is the thickness of the wall 200 millimeters thick? Then your answer yes. Alright, so every time that you're not given details in the drawings and you're not given the same details in the specification, you need to make yourself a query sheet. Alright, so when you're taking off, you should not leave anything not measured because you're not given any details. You should just make an assumption, but you cannot make an assumption without a query sheet. All right, thank you so much for understanding that. Okay, so before you take off, the first step that you do once you get to a taking off exam or assignment is to study your drawings. All right, you need to understand what are the measurements standing for. Are they external dimensions? Are they internal dimensions? Are there measurements that are not there? You need to study your drawing, all right? Because, for example, this is the plan to our building. The plan, we can see we have an external wall, all right? We have an external wall, and we see we have an internal wall. All right, we can see that here we have external dimensions 11,675. Then we have these other dimensions. We need to understand from where up to where. We need to see that this plan has a recess at the center and it has a recess at the corner. All right, then we need to see that we have been given the thickness of the wall as 225. All right, if this is 225, this could guide you to know that this is 225 on the section. So we need to also see that in the plan we have an internal wall. I hope we saw that we have an internal wall. Okay, then we have section AA. Once the section is taken, this one is section AA. This one, I forgot to write here. This is section AA. You see, in the section, we expect to see this wall and this wall. All right, so in the section we will look for this wall. This wall, it is this wall, all right, because it cuts across a. So once it cuts across, this wall is this wall. Where is this wall? You see that wall, we can see a wall here, and this wall, it's written 150 millimeters wall. You see, this wall must have been this wall. But this wall now, we understand from this drawing that it is not a substructure wall. This wall does not exist in the foundation. It only exists in the superstructure above the slab. Alright? Now, once we have noted that, we have seen this wall, which is this wall, which is similar to the whole external wall going round. This wall has a strip footing. Alright, so it has a strip footing here, and the strip footing is made of concrete, of course. Then this one here, we have a blinding. Here we have blinding, and this one, I told it's 50 millimeters thick concrete. You see, any layer of concrete that is so small, like 50 millimeters, it's a blinding layer. It is usually done in preparation to receive the vibrated reinforced concrete. So this one is 50 millimeters thick concrete, ratio 1:4:8. Once we are studying the drawing, we shall be able to see, to observe this. The width of the foundation trench is 675. The thickness of the concrete, the vibrated reinforced concrete, is 225. All right. Then the height of the wall from the above the concrete to the ground level is 2100, right? Yes, so from above the concrete to the ground level is 2100. Then from the ground level to the top of the concrete is 250. We need to study the drawing, because when we are studying the drawing, that is when we shall understand anything that we are not given, what we'll be needing a query to prepare query sheets for. Then we will be able to understand the measurements, how they are placed, so that when we come to measuring, it could be easier for us. Then we need to see that in this section we have hardcore, and hardcore is 575 millimeters deep. Then we have 25 millimeters. This one is maram. Then 150 millimeters. This is concrete, oversight concrete. Then we can see that there is a DPC, damp proof course, below the wall, superstructure wall. Then we need to see, you see this concrete was vibrated reinforced concrete, ratio 1:2:4. Why is it reinforced? Because we have a BRC mesh. You see, this is a BRC mesh whose mass is whose density is 1.22 kilograms per meter squared. Then the class of the BRC is A142. Then we are told that above the maram, on the top of the maram, we have a 1000 gauge polythene DPM on the maram. Alright, so after that, we have studied the plan and the section. We have to study also the notes that we are given. We are told that the site is bushy, okay? Then we are told the vegetable soil average is 150 millimeters, and it is to be preserved on site. Once you're told it's preserved on site, please do not take it away from the site when you're taking off. You need to preserve it on the site. All right, if you told the site is bushy, what does that tell you? You need to do site clearance. Okay, now I hope you're getting to understand these things. You see, taking off is quite easy. It seems a bit complicated to students the first time, so if it's a bit hard for you, don't worry. It has always been hard for students the first time, but the moment you continue practicing, studying more, you need to watch a variety of videos, you need to read several books, and of course if you come to and listen to my classes, of course you understand it quite easily, because I try to simplify it to the core, and to simplify it for you so that you can just absorb it. All right, so you see, we have studied the plan, we have studied the section. Now, in the next step, now we need to begin taking off. And I want to take you through the whole process of taking off substructure works. Alright? How we come up with a takeoff list. So if you're new here, or you have been coming to a channel and you haven't subscribed to a channel, kindly, may you take this 1 minute just to subscribe to a channel. You see, if you subscribe to a channel, that is support that you're giving us. so that we can be able to grow as a channel. If we are able to grow, we are able to get more facilities so that we can be able to teach you the same things we are teaching you. You see, this is a student-oriented channel. Our main and only aim is to assist students understand quantity surveying concepts that sometimes they are quite hard in class. You see, why I started this channel is because I realized that I could not get simplified materials to study taking off, and also my students were struggling to get these materials. So, and I got other complaints from other trainers that they could not be able to get these materials easily, and most of them were struggling to understand takeoff. So I decided to, because I had studied this takeoff thing, and because it is my passion to do these bills of quantities and to understand everything that is entailing estimation and costing and building of bills of quantities, to come and explain it in this YouTube channel. So kindly assist us to grow, and once we are growing, we'll continue to provide more content for you and for free, so that you can be able to understand. You see, quantity surveying brings you a lot of money. Once you understand how to do bills of quantities, then you get to the industry. You can testify that the construction industry has a lot of money. So without further ado, kindly subscribe to our channel, and also click on the notification bell, so that whenever we upload these good videos that you're asking, we only upload videos that are requested by you. You can be notified so that you can come and watch. Thank you so much for subscribing. I really appreciate your support. May God bless you. So we shall go to the next step. You see, when taking off, when you are taking off, we need to come up with a take-off list. Take-off list. And sometimes we usually call it a checklist. You see, how do we come up with a take-off list? When we are coming up with a bill of quantity, the first process is usually to measure. Taking off is just measuring. For example, we shall measure the areas of the walls. We shall measure the volumes of the concrete that we shall use. We shall measure the length of the reinforcements that we use. Why do we measure? Because when you come to the bill of quantities, I'm going to show you in a concurrent video what a bill of quantity is, and I'm going to take you through an example and how we fill it in. But in the meantime, you need to know that a bill of quantity usually have columns which describes the work, which gives us the measurement for the work. For example, an area of the wall, we could say it is 50 meters squared area of the wall. All right, so in the description you could be told it is 200 millimeters thick wall. Then in the measurements, now that which we shall take off, once you measure, for example, okay, what will determine whether we should measure the length of the wall or the area of the wall or the volume of the wall is called this method of measurement. Maybe you have heard of the SMM or the NRM2 or the ARM4. All these are the methods of measurement that guides us when we are doing measurements. The methods of measurements, it's just like a method of measurement is like a quantity surveyor's Bible. It gives us the guidelines on how we should measure. For example, different countries that have the same methods of measurement measure their walls in the same way. You see, the method of measurement guides every quantity surveyor how they should measure, the unit of measurement they should use. For example, if the SMM, the standard methods of measurement, right now we are using this SMM7. If the SMM7 tells us that areas walls should be measured in terms of area, then we shall know that in the bill of quantities, the unit for the wall should be in area. Now, if we have measured the area of the wall and we have realized our small building has 400 millimeters squared of the wall, how do we know the cost of the wall? That is where we come up with the unit rates. You see, in our videos, we have done quite a long playlist showing you how you come up with the unit rate. Now, in the unit rate, it will be telling us the cost per meter square of constructing the wall. In the unit rate, that's where we shall find what will be the cost of materials for building the wall, what will be the cost of labor, what will be the cost of the plant that we could be using. Okay, then we shall add the profits and the overheads. Then we shall calculate the cost per meter squared. Then, assuming that we had 200 meters squared of the wall, once we multiply by the cost of the wall per meter squared, assuming it's like 150, so we shall take 200 meters of wall, 200 meters squared of the wall is the wall. Okay, the building has 200 meters squared of the wall. Then we shall multiply by the cost per meter squared, like 150. Then we shall get the cost of the wall, right? Hi everyone, welcome back to our YouTube channel. My name is Naomi and I'm going to take you through taking off substructure works. In a previous video, I introduced to you how we do taking off for substructure works. We also have a couple of videos, both on PowerPoint and handwritten, that explains to you how we do taking off substructure works. We are so grateful that you're here, and in this channel we help students understand bills of quantities, quantity surveying concepts, the whole process of coming up with bills of quantities and estimating, costing, building and civil engineering works. So in this channel, for all our new viewers, students ask for videos, then we do them for them. For example, there is a video that they asked for, explain to us, like beginners, how to do taking off. We did one video and there are a couple of questions in that video, and in today's video I'll be explaining taking off substructure works in the simplest way possible for a bit complicated building, a bit complex, because in the previous video we did a rectangle, but in today's video we will have a building that have. The trenches are always excavated from the reduced level. Have I said it clearly? The trench. The trenches are always excavated from the reduced level. Have I said it clearly? The trenches are always excavated from the reduced level. Okay? Do not excavate trenches from the ground level. Do not excavate trenches from the stripped level, but excavate trenches from the reduced level. We never excavate trenches from the ground level. So the whole site, by the time we have reduced the level, the whole site where the building will occupy together with the foundation spread is at the reduced level. From that level is where we excavate the foundation trenches. So the fourth step is excavating foundation trenches. Number one, we always award marks for the takeoff list, at least 2 marks for the takeoff list. All right, then why we come up with a takeoff list is so that we can be able to use it as a reference to know whether we have taken off and we have done takeoff for every element that we had stated we need to take off. Then how we come up with the takeoff list, the same order or procedure we do when we are building something. It's the same procedure or order we shall use when coming up with a takeoff list. We state all the elements that we need to measure. Then we come taking one by one once we have measured them. All right. For example, once we are doing taking off for substructure works, the first step we shall do when we get to site is site clearance. All right. So when you are coming up with a take-off list, we need to write that as the first item. The first item is site clearance. You see, once we get to site, we need to measure where we need to do the site clearance. First of all, we clear the site. Then we remove the vegetable soil. You see, once you clear the site, maybe there was vegetation, there was grass on the site, there were shrubs that were growing, there were undergrowths in the site. We had to cut down the trees, we had to demolish the buildings. All right. If there was vegetation, we need to remove the vegetable soil. The vegetable soil is that soil that supports growth of vegetation. So every time we clear the site of vegetation, we need to remove the vegetable soil. And in like our drawing, we were told the vegetable soil was average 150 millimeters deep. So we shall maybe use an equipment. The one that sweeps away all the vegetable soil. Maybe you can tell me in the comment section. I forgot the name of the equipment. So we could use that equipment to come and sweep away all vegetable soil to a depth of 150 millimeters deep. Then the same area that we clear the site, we shall remove the vegetable soil. Then after removing the vegetable soil, we need to know whether that level that we have attained is good for construction. You see, in places where we have red soil is good for construction. Maybe even after the vegetable soil, the soil could be steady enough where we could lay the hard coal. You see, when we are taking off, maybe I could have not explained to you, there's something you need to understand very carefully. There are 3 levels that are there when we are measuring. For example, once you come to this, this one is the ground level. Once we get to site, that the level the site is at is called the ground level. That level is where is the level where vegetation grow. There were buildings that were existing, the trees were growing. That was the ground level. You have just got to a new site. That level you have found the site in is the ground level. The ground could be covered by vegetation, it could be covered by buildings. Now, after the ground level, once we remove we clear the site and we remove the vegetable soil, the level that we get to is the stripped level. Maybe you can say it with me. After the level that you find on site is called the ground level. The level that is found after removing the vegetable soil is called the stripped level. Then after stripping the ground level, after removing the vegetable soil, we get to the stripped level. If that level is not stable enough for us to lay our hardcore, we need to excavate further. You see, the formation level is the level where we lay our hardcore. Any level that we lay our hardcore, because the soil there is stable, is called the formation level. If after removing the vegetable soil, that in that level, the soil is not stable enough, we need to excavate further. All right, we need to excavate further until we get to the reduced level. Okay, once we excavate further, that level we get to is called the reduced level, because we have reduced the level further, we have gone deeper. Now that reduced level that we get to, where the hard coal now can be laid and the soil is stable, that level is called the reduced level. So let me give you a recap of the levels. The ground level is the level that you find on the site. Then we have the stripped level. The stripped level is the level that you attain once you remove the vegetable soil. You uncover. You see, stripping is uncovering. Okay, now you have uncovered the ground of all the soil that was covering the vegetable soil. Now we get to the stripped level. Then the stripped level could be the formation level in case the soil is stable enough where we can lay our hardcore. But if it's not stable enough, we should reduce it further. Whenever we go deeper, we are reducing the level. Okay, so you see we are reducing the level because at sea level, that is where the level is 0. Okay, the deeper we go, the more we are reducing the level. So we shall reduce the level, and that reduced level could be now the formation level, because the formation level is where we lay the hardcore. So these are some of the terms that you shall come across when you are taking off. So we have cleared the site. Another good thing you should note is that when we are measuring things like site clearance, we are not measuring site clearance for the whole site. No, for the whole site is usually measured under preliminaries. You see, there are these things that we do prior to constructing in the site. We need, maybe the site was very bushy. We consider the walls of the building, but then we also consider the foundation spread. You see, there is, you say I don't like using new terms to new students, but as you continue to listen, you'll be able to understand. I'll make sure that I explain them to you. When we are constructing this building, when you are constructing these walls, and they are in the foundation, you see, in the foundation, they are inside the soil. We need to do trenches. Trenches are, the walls are usually constructed in a trench. A trench is a hole going round. In simple, I don't know whether it's understandable, but it is a hole going round everywhere the wall will be. So the wall will be positioned at the center of the trench. Now, when we are constructing this wall, we cannot just come and excavate only where the wall will be at. We will have to give some space. You see, this is if the trench, okay, if this is the wall, the substructure wall, then we need to do a trench. The trench usually is wider. Why is it wider? It is because we need, first of all, to lay this concrete, and this concrete occupies the whole trench. Then another reason is because once we are constructing this wall, we need somewhere for the workers, the skilled and the unskilled workers, to step in. You know, a trench is usually excavated from the ground, so it's a hole, and we are constructing these walls inside that hole. So we need some working space on this side of the wall and on this side of the wall. All right. So we usually excavate a trench which is like 675 millimeters wide, though the wall is 225. This space that is called inside, you see, the wall is constructed at the center of the trench. So this space that is outside the wall but inside the trench is called a foundation spread. This one is foundation spread on the outside, then this one is foundation spread on the inside. This is a foundation. You see, foundation is anything inside the ground. Alright, below the ground level. You see, from here, everything is below the ground level. The trench was 675 millimeters thick. Alright, I'm repeating it so that you can understand very clearly. The trench is 675 millimeters wide. Alright, then we are constructing a wall 225 millimeters thick at the center of the trench. Alright, so if we are constructing a wall 225 millimeters thick at the center of the trench, then the trench is 675. There is this space outside the wall but inside the trench. You see, a trench is a hole. Then the wall we are constructing inside that hole. So there is this space outside the wall and inside the wall. That space, we call it working space. Okay, and we can also call this the foundation spread. So how much is this foundation spread on the outside of the wall? We shall take 675, we deduct 225, then we divide by 2 because there are two sides. All right, so we could take 675, then we deduct 225, we get 450. So we shall take 450 divided by 2. We get 225. So it means from here up to here, it's 225. This is the foundation spread on the outside. Then this one is the foundation spread on the inside, 225. Right? Now, once you see, this is the wall of the trench. I hope in that section you can be able to see where is the wall of the trench on the plan. You see, the wall is constructed at the center of the trench. So if we were to sketch the trench, we could say that the trench, the external wall of the trench could be are symbolized by a broken line. It could be symbolized by a broken line with a distance of 225 from the wall. This is the external wall of the trench, because we said the trench is a hole, so it have an external wall and an internal wall. Okay, so the one that I've sketched is the external wall of the trench. Then the internal wall of the trench could be also a distance 225 from the internal of the wall, now on the inside. So when we are setting out a building, we usually measure where the trenches will be. Then the walls will automatically be placed at the center. All right, so those broken lines can show you where the trench shall be. So the trenches shall be, there is an external wall of the trench and the internal wall of the trench. So when we are measuring site clearance, get this very clearly. This one you have to take it to the bank. When we are measuring site clearance, we usually measure the area of the external walls of the trench. Okay? When we are measuring site clearance, I repeat, we usually measure the area of the external walls of the trench. The external walls of the trench are usually the one symbolized by a broken line outside the wall of the house. All right, so how we measure the external walls of the trench, we shall take the external dimensions of the building plus the foundation spread both sides. You see, like this one, from here the external dimensions was 8,000 plus 4,000, which is 12,000. Now, so that we can get the external dimensions of this trench, we shall take 12,000 plus 225, then plus 225 for this side. All right, so when we are measuring the external dimensions of the trench, we usually take the external dimensions of the buildings plus the foundation spread on both sides. That one you have to remember, and it's the simplest way you can remember that. When we are measuring the area of site clearance, we usually take the area of the external dimensions of the trench. Okay, so the external dimensions of the trench, we take the external dimensions of the building plus the two sides of the foundation spread. All right, so the same area that we do site clearance, the same area we shall remove the vegetable soil. You see, because once we shall have removed, we shall clear the site where we have the, we shall follow the external wall of the trench. The same area we shall come and remove the vegetable soil. All right, and the same area we shall reduce the level if we need to reduce the level. How do we know whether we need to reduce the level? Before we go to that, in the takeoff list, this is site clearance. The second one is the removal of the vegetable soil. Removal of vegetable soil. Now, we know we need to go to the third step, which is reducing the level. But do we know whether we need to reduce the level? You see, how do we know whether we need to reduce the level? Whether we need to reduce the level or not, we need to get it from the drawings. The drawings should guide us whether we need to reduce the level. How should we do that? Okay, come with me. In the drawings, you're told this is the ground level. Okay, and you can see that from the ground level, we have this hardcore. You see, this hardcore is 575. All right, so so that you can be able to know how much is from here. You see, the ground level is from here up to here. We need to know how deep is it from here up to here. How do we get that? If we could get the depth from the top of the concrete to below the hardcore, then we deduct from the top of the concrete to the ground level, then we could find from the ground level to below the hardcore, right? Okay, so come with me, let us take, we shall take 575 plus 25, we get 095, 590. We add 150, we shall get 740. Is that true? No. Here we got 5 plus 5, 0, carry 1. So this one is 600. This one is 600. 600 plus 150, we get 750. Mathematics. Okay, so from here up to here is 750. We have got from the below the hard coil to the top of the concrete 750. Then we need to deduct the depth from the top of the concrete to the ground level, which is 250, right? So so it shall be 750 from here up to here. We deduct 250 so that we get from here up to here. So 750 minus 250, we get that from here up to here it's 500, right? So if from the ground level to the formation level is 500, and we had cleared the site 150 millimeters of vegetable soil, okay, the ground level to formation level 500. Then we remove the vegetable soil at depth of 150. How much more do we need to reduce the level? Okay, so from the ground level, you see, from the ground level was here. Then we have the formation level here. This depth is 500. Then we already came and removed a layer of the vegetable soil. From the ground level, we removed a layer of the vegetable soil, which is 150. So what is this remaining from here up to here? We shall take 500 minus 150. So we shall take 500 minus 150, we shall get it 350. So we shall say that we already cleared the site, we removed 150 millimeters deep of vegetable soil, then we now need to reduce the level by 350 millimeters so that you can get to the reduced level. Am I clear? I hope I am clear. So 150 millimeters deep is the depth we shall remove the vegetable soil. Then we need to reduce the level by 350 millimeters deep. Alright, so in the take-off list, we shall say we need to reduce the level. Alright, so after site clearance, the same area we shall remove the vegetable soil, then the same area we shall reduce the level. Now you see where we have the external wall of the trench, the outside broken line, all that area is the area that we are concentrating in. And in that area, the ground level, the level at that area now, by this time, after we have reduced the level, it's 500 deeper from the rest of the ground on site. Where the building will occupy together with the trench will be a bit lower by 500 millimeters from the ground level. Now, where shall we begin excavating the trenches? The trenches are always excavated from the reduced level. Have I said it clearly? The trenches are always excavated from the reduced level. Okay? Do not excavate trenches from the ground level. Do not excavate trenches from the stripped level, but excavate trenches from the reduced level. We never excavate trenches from the ground level. So the whole site, by the time we have reduced the level, the whole site where the building will occupy together with the foundation spread is at the reduced level. From that level is where we excavate the foundation trenches. So the fourth step is excavating foundation trenches. Excavate foundation trenches. Alright, foundation trenches are usually excavated from the reduced level. Alright, so to know the depth of excavation of the trenches, what shall we do? Alright, now from the ground level, you see the whole site is at this level. The whole site is at this level. This is the reduced level. Now we shall excavate the trenches from here to below the foundation, below the foundation trenches. What is this depth from here to here? How do we calculate that? Of course, we can calculate that by taking the total depth. You see, if we take the total depth here, up to below the blinding, we take 250 plus 2100 plus 225 plus 50. Then we deduct from the top here up to below the hard core. Then we can get the remainder from here up to below here. Okay, should we do it so that you can be able to see? All right, so I need to rub. I need to rub so that you can be able to see it very nicely. So the depth from here up to the ground level, from the top of the concrete to the ground level is 250. From the ground level to the top of the concrete is 2100. Let's go adding 0, 5, 3, 2. Then from there, now we are here. From this concrete, thickness is 225. So it shall be 5, 7, 5, 2. So up to here it's 25, 75. Then we add 50. 50 for the blinding, because you see we excavate to the bottom of the trenches, and at the bottom of the trenches, that's where we lay our blinding. So it shall be 5, 2, 6, 2, 26, 25. All right, so the depth from below here to the ground is 26, 25. Now we need to know from below the hard core to the trenches is how much. So it shall take 26, 25. Then we less, we need to do the total of these layers. So concrete was 150, maram was 25, and hardcore was 575. So it shall be 5 plus 5, 0, carry 1, 8, 10, 15, 750. So these layers amount to 750. Yes, we had added them here. So we shall take 26, 25, we deduct 750, and we shall get 5, 7, 5 minus 7, 15 minus 7, 8, 1875. All right, 1875. 1875 is the depth from the reduced level to the bottom of the trenches. Is it true? Okay, let us go through the calculation again. From the top of the concrete is 250 plus 2100 to the top of this one, then plus 225 plus 50. All right, yes, we get 2625. Then for the concrete it is 750. So the depth from this one shall be 2625 from the top to the bottom. Then you deduct from the top to the, so it shall be 1875. All right, so the total depth we shall need to excavate from the reduced level to the bottom of the trenches is 1875. When we are excavating trenches, according to our method of measurements that you're using today, the SMM, we usually excavate trenches in ranges, in stages of 1.5 meters deep. What do I mean? That when we are excavating the trenches, we usually excavate the first 1.5 meters deep is separate cost to the next 1.5 meters deep. Okay, so we shall excavate the first 1.5 meters deep separately, then the next 1.5 meters deep separately, then the next 1.5 meters deep separately. Why do we do that? It's because the cost of excavating near the ground level is cheaper. It's cheaper than the one when you're excavating in deep levels. Okay, the cost goes changing. So we should always calculate the volume of soil in the first 1.5 meters deep, then the next. We should separate these stages because the different stages have different costs. Because the deeper you go, the more expensive it becomes. And excavating the soil is usually costed per cubic meter. All right. So once we have a depth of 1875, we need to know how many stages shall we excavate this 1875. You see, the first stage, you will take 1500. So it shall remain with 375. So this one will be the first stage. This one will be the first stage, then this one will be excavated in the second stage. Now, in the excavation of trenches, you should note that when we are writing them in the description column, we shall state that we are excavating for foundation trenches depth not exceeding 1.5 meters deep from the reduced level. From the reduced level, not exceeding 1.5 meters deep. Then, the next stage, we shall say, we shall excavate from 1.5 meters deep, not exceeding 3 meters deep. Alright? So, in the description column, you should always write from where you're commencing up to where. So, commencing from the reduced level, not exceeding 1.5. Commencing from 1.5 meters deep, not exceeding 3 meters deep. Okay? Okay, yes, that is exactly what we should do. Then, in the measurements, in the booking column, you should find the volume of the soil in the trenches. You see, volume normally is usually equals to length times width times height. Okay? Height can be depth. Now, in the trenches, how do we find the length of this trench? You multiply by the width of that trench, then you multiply by the depth of the trench. How do we find the length of the trench first of all? So, this brings us to center line. We have been talking about center line in this channel. I have done almost 7 videos showing you how to calculate center line. And I've shown you the simplest way to calculate center line. And it is in our videos. Could you kindly remember how we calculate center line? Okay. I see you remember. Some of you do remember, some of you cannot remember, and some of you do not even know. Don't worry, you need to check out our video on center line. It will show you the simplest method on how you should calculate center line. But I will remind you the formula. The center line of example, a trench is equals to the external perimeter of the trench. We deduct number of corners times the thickness of the trench. Let's go to center line of the wall. The center line of the wall is equals to the external perimeter of the wall. You deduct number of corners times the thickness of the wall. If it's the wall, it should be wall, all through. Okay, let's go to a center line of concrete. Center line of concrete is equals to the external perimeter of the concrete. Then we deduct number of corners of the building multiplied by the thickness of the concrete. Alright? So, center line is what we shall use. For example, this is in excavating the trenches. So, we have said the center line of the trench is equals to the external perimeter of the trench. We deduct number of corners times the thickness of the trench. We could be having sometimes internal corners like these ones and external corners like these ones. So how do we calculate number of corners? Number of corners is equals to external corners minus number of internal corners. Let me say that again. Number of corners, we get it by taking number of external corners minus number of internal corners. For example, in this building, how many external corners do we have? Okay, we have 1, 2, 3, 4, 5, 6, 7 external corners. How many internal corners do we have? We have 1, 2, 3. So, how many corners do we have in this building? We have 7 external corners minus 3 internal corners. So we have 4 corners in this building. So how do we calculate the center line of the trench? The center line of the trench is the external perimeter of the trench. We deduct number of corners times the width. We have said that to get the volume of soil in the trenches, we need to take the center line of the trench times the width of the trench. The width of the trench is 675. Then we shall multiply by the depth of the trench. Alright, so I hope we are at par when it comes to excavating the trenches. The next thing that we need to do after excavating the trenches, you know, after excavating the trenches, there could be water in the trenches. You see, there could be places where there could be water in the trenches, or the soil could be black cotton soil, or another type of soil that needs support of the trenches. You know, soil collapses. You know that, eh? So the deeper we have excavated, if we have excavated deep, we may need to support the walls of the trenches depending on the type of soil. If you're not told whether to measure the support of the trenches, you can just write an item. Okay, I don't want to tell you to write an item. I want to explain to you what is an item first. Item, you shall find it in our takeoffs, and item is usually there to symbolize that whatever we are supposed to measure cannot be measured accurately from the drawing. So a provisional sum will be given in a bill of quantity. A provisional means it a sum of money that may change. Okay, so a provisional sum will be given to all items in the takeoff when we come to transferring to the bill of quantity, so that that money is allocated temporarily. Provisional is in the meantime before we go to know the extent amount of work. You see, a bill of quantity is that document that tells us the cost of the building before we get to site. And tenders and contracts are entered into using the bill of quantity. So everything has to have a cost implication in the bill of quantities, whether we can measure it accurately or not. So though that sum of money that we usually give in the bill of quantities for works that the full extent cannot be measured from the drawings is called a provisional sum. The full extent of the work shall be known in the site, all right? But now we need to allocate some money just in case we shall do the watering, just in case we shall support the walls of the foundation trenches. So the next item, or so in the taking off, we usually write items. The two items that we shall measure is the watering, removing the water from the trenches, and also planking and strutting. Planking and strutting is the support to foundation trenches. These two items, we shall write item. You shall see I have done a full takeoff of this one on the book. So once I have introduced this takeoff, kindly check out our next video. I have done it detailed takeoff from the beginning to the end, measuring and booking all those dimensions in the takeoff sheet. So this is the introduction video, but by the time you will be going through it, you shall see items. Where instead of doing the areas, the volumes, or the linear meters or the numbers, we shall write item in the dimension column. And this one symbolizes the works that cannot be measured accurately from the drawings, like the watering the trenches and planking and strutting. Once we have removed the water and we have supported the foundation trenches, if need be, we should now go to the concrete. All right, the foundation concrete. The foundation concrete should be the next item. The foundation concrete. The foundation concrete, you see, in the foundation we have the concrete. We have this concrete here, and we have the blinding. All right, then we have the reinforcements. So all these three items we need to take off. So in the foundation concrete, we need to take off the blinding first, then we need to take off the concrete, then we need to take off the reinforcements. Okay, so what shall we be taking off in the blinding? If you look at the method of measurement, how should we take off the blinding? The blinding is usually measured in area. So we shall measure the area of the blinding. Remember, this brings us back to the center line. How do we calculate the area of the concrete in the foundation? All this area where we have the trenches, we shall have the concrete, the blinding, the 50 millimeters blinding. We want the area. When we were calculating the volume, we took center line times the width times the depth. Now we want the area. What do you think we should do? Of course, we should take the center line times the width of the trench. So we shall take the center line of the concrete, which is the same as the center line of the trench, because the concrete occupies the full width of the trench. So the center line of the concrete times the width of the concrete, we shall get the area of the blinding. all right, because the blinding is 50 millimeters thick. Because it's a thin layer, we usually calculate the area. Then we go to the concrete. The concrete is 225 millimeters wide, all right. So for the concrete, we usually calculate the volume of the concrete. How do we calculate the volume of the concrete? The volume of the concrete will be equals to the center line of the concrete times the width of the concrete times the thickness of the concrete. How do we calculate the center line of the concrete? The center line of the concrete is equals to the external perimeter of the concrete. We deduct number of corners times the thickness of the concrete. How do we calculate number of corners? The number of corners will be equals to a number of external corners minus number of internal corners. Very good. You have understood that. So in the concrete, we shall take the center line of the concrete times the width of the concrete, which is 675, times the thickness of the concrete, which is 225, right? Then we shall go to the reinforcements. The reinforcements, you see, we have these reinforcements and they are going everywhere around the trench. We have these reinforcements, they are aligned like this. Then we have other reinforcements, the ones that you can see the dots, they are lined up like this. So how many are lined up across along the trench? You see there are those that are lined up along the trench. We can only calculate the dots. We count 1, 2, 3, 4. So those four reinforcements, they are going along the trench everywhere. Then we have other reinforcements that have bends crossing over all of them. So how do we calculate? First of all, the length of one reinforcement bar, that is coming across the trench. They cross the trench. The length of this one reinforcement bar, we could take 675, which is the width of the concrete. Then the reinforcement bar do not go from end to end. We always leave a concrete cover between the reinforcement and the concrete. So if we had a cover of 25 here, you see the cover is this space between the reinforcement bar and the concrete. If we leave a cover of 25 and here 25, what will be the length from here up to here? It will be 675 minus 25 minus 25. And 675 minus 50 is 625. Then we shall add these bends. We shall add the bends. All right. So, so that we can add the bends, we could say the bends are 50 millimeters, because we have not been told. We could say the bends are 50 millimeters. So we shall take 675 minus 50 plus 50 plus 50. All right, that will be the length of one reinforcement bar. How many reinforcement bars? To calculate the number of reinforcement bars, we shall take the total center line, because they are distributed along the center line. We divide by the spacing of the bars, and we are told the spacing of the bars. You see, I did not write it here, but this one was labeled maybe D12 bars at 200 millimeters center to center. So they are D12 bars. They are placed at 200 millimeters center to center along the center line. So we shall take the total center line divided by 200 plus 1 to get the number of the reinforcement bars. So we shall take center line divided by 200 plus 1. That is, we shall get the number of those reinforcement bars across the trenches. Then the length of one bar shall be, you take the bend plus this length plus the bend. All right, once we multiply the number times the length of one bar, we shall get the total length of the D12 bars that are across the trenches. For the ones along the trenches, we shall take the total center line, it is the length of one bar, then we shall multiply by 4 bars. You see the ones that are going across the trench, they are 4 bars. So you shall take 4 times the length of the center line. So 4 times the center line, we shall get the length of the bars that are going along the trenches. And that one is an introduction to taking off this one for the reinforcement. If you check out the next video that I have done on the screen, showing you how you measure detail by detail, the same diagram that I've done here, you will be done, you will have understood everything. You'll be so good with takeoff. So kindly check out for that video that I'll upload after this one. You see this one, I have done it so that I can introduce you in detail. You can see it as I point for you on the board so that you can understand. Once you have covered this, go and do that one for takeoff. Then just focus on the drawings do it yourself, mark for it using that video, and that is how you learn. By the time you are done with these videos, you'll be so good with doing all the BQs that you need to, because taking off is something that is so easy, so interesting. Quantity surveying is something, it's a sweet subject. It is something that you enjoy doing, right? I know you can bear me witness. The moment you just concentrate and you just decide that you want to understand these things, and you decide that your passion is here, you'll just find yourself flowing and enjoying the quantity surveying field. Okay, all right. So we are done with the foundation concrete. Now we are here. We are already done with the foundation trenches. Now we want to know what is the area, the foundation walling. So the seventh, in the takeoff list, after the foundation concrete, the next item we shall go to is the foundation walling. How do we take off the foundation walling? The foundation walling is 225 millimeters thick. Then when we are taking off the foundation walling, we need to find the area of the wall. How do we find the area of a wall? The center line of the wall times the depth of the wall. How deep is the wall? The depth of the wall is from the top of the concrete to below the concrete here. So if we want to find the depth of the wall, simply it's taking 2100 plus 250 deduct concrete, because it starts from here up to here. You see that wall goes even above the ground level. Alright, so you shall take 2100 plus 250, then we deduct 150, shall give us 2200. That is the length of the height of the wall. So the area of the wall shall be the center line of the wall, which is the center line of the trench times the height of the wall. Very good. So we are done with the foundation walling. So the next thing we shall go is hardcore. You see, hardcore. You see, when we are taking off hardcore, the thing that you're supposed to note very keenly, I have paused there. Hardcore cannot be placed on top of the walls. Please get that clearly. Students, I have seen students take off hardcore on top of walls. We cannot place hardcore on top of a masonry wall. What will be the hardcore for? Hardcore is only placed on the soil, alright? Because we want to make the soil stable enough to receive the concrete. So hardcore, whenever we are taking off hardcore, we always take the internal dimensions. You remember that in this video I have not considered the voids. The voids is a whole other video. I will do another video showing you how we should deduct these voids. First of all, I'll take you through this process, then I'll do a video for the voids, then we'll go to the taking off itself. Okay, now the hardcore, we usually take the internal dimensions of the building. Hardcore is laid inside the walls. So in a case like this one, if this wall, the external dimensions was 8,000 plus 4,000 plus 5,000, giving us 17,000. 17,000 cannot be the length of the hardcore. The hardcore, we have to deduct the walls. You see? We need to deduct the walls because the hardcore is laid inside the walls. So the key to note, whenever we are laying hardcore, and okay, maram blending is also done on the hardcore, and what else? The hardcore and the maram blending is usually measured inside the walls, the internal dimensions. It's laid inside the walls, I repeat. So whenever we are finding the areas, okay, hardcore is usually, if it's a thick layer like 575, if you look at the SMM, we measure it in volume. So if you want the volume, you'll take the length times the width times the depth of the hardcore, which is 575. Okay, then the difference between taking off hardcore and maram blinding is that hardcore is measured in volume, but maram blinding is measured in area. Alright, so for the maram blinding, we will take the internal length times the internal width, but it is only the area. So this one is measured in meters squared, but this one is measured in meters cubed. That is the difference. But it is the same area that hardcore occupies, is the same area that maram blinding occupies. All right. So hardcore is measured in meters cubed. Maram is measured in meters squared. All right. Then after that, we shall go to the next item, which is the anti-termite treatment. Anti-termite treatment. How do we measure the anti-termite treatment? The anti-termite treatment is always measured the same area that maram blinding occupies. Then after the anti-termite treatment, we shall go to the DPM, damp proof membrane. The DPM is usually laid even on top of the walls. Okay, the DPM goes even where the wall is. The DPM is, we take the external dimensions. So we shall take the external length, the external width of the drawing. So DPM, we usually take the external dimensions. So for all this, we usually take the internal dimensions. Then for the DPM, together with the concrete, you see we have the concrete, then we have the BRC inside the concrete. All these, we usually take the external dimensions. All right. So these ones we shall take the external length, the external width. All right. Then we are done with the DPM, the concrete, and the BRC. All right. Okay. So for the DPM, we shall find the area. The concrete, the oversight concrete is the area using the external dimension. The BRC is the area using the external dimension. Because if you see, the BRC goes even to the top of the wall. And the drawing will show you very clearly what is inside the wall and what is not inside the wall. What is above the wall. Alright? Yes. So after we are done with, you see, in concrete, we need to take off the formwork for the concrete. You see, around the foundation, after we have done the foundation walling, before we do the concreting, we usually do formwork around the foundation on the external wall so that it can support the concrete. The concrete cannot pour outside. So the concrete is usually, the formwork is usually measured in linear meters. And the formwork, we usually find the perimeter of the external of the wall. The external perimeter of the building is the length of the formwork. I hope that is clear. I'm just saying points. Not every point that I say very keenly. The length of the formwork for the concrete that supports the oversight concrete, we shall just need to calculate the external perimeter of the wall. Okay, because the formwork is placed on the external perimeter of the wall. Then the last thing we shall do is adjustments for the soil adjustments. So for the soil adjustments, we usually, there is soil that we excavated. We excavated when we were reducing the level. There is soil that we excavated when we excavated the trenches. There is soil that we shall use to backfill, and there is soil that we shall take away from the soil, from the site. I have done a whole video on soil adjustment, taking off earthworks. Kindly, the video, I shall link it in the description box. Go and watch that video. It explains to you the whole process of how you adjust this video. There's soil called refill and ram. There's soil called cut away. There's soil used for backfill. I will not explain it in this video. Kindly check out for that video so that you can understand in detail. We have done the introduction part for taking off substructure works. I know I have not covered the voids. I will do another video for the voids to show you how you deduct the voids. Then you will look at exactly these drawings. I have taken them off and I have done a good video for you guys, so kindly check it out. So thanks a lot for watching our introduction part. Just in case you have any questions that you would want me to cover, maybe you have not understood and you're wondering somehow you have not understood, kindly write it in the comment section. I'll be going through all your comments and I'll be able to answer them. We are sorry for those ones that we have not answered in the past. We have been very busy, but now we are creating time for you guys because you're already subscribing, right? So continue to subscribe to our channel. Kindly share our content with your classmates so that they can know about our channel. Let them come on board, because here we want just to help you students understand this concept in the simplest way possible. I know most of you have really improved, and you have told me in the comment section how much our videos have been our blessing to you, so you have been able to understand. So we are here to assist you guys. Kindly share our content, like our videos. If you have liked these videos, just give them a thumbs up so that other people can be able to see them. And once you do that, for sure we shall continue to make good videos for you, and your education will be much easier, and you'll enjoy the quantity surveying field. This quantity surveying field, as I always say, is the sweetest field to be in. If you build your passion here, mathematics becomes so sweet, and measuring becomes something that you're addicted to. You just love it. All right, so I hope this attitude still gets to you, that measurements is something that we just enjoy in this channel. And even as we grow together, let me know what you want us to cover next. I will be doing classes like this on the board, maybe, because for the PowerPoints most of you are not able to and follow them well. I'll be able to do them on the board, and sometimes for those examples that we need to take off, I'll do them on the screen, so that you can be able to follow through how it should be written in the dimension paper. So thank you so much guys. I look forward to seeing you in the next video. I look forward to reading your comments, and I look forward to see you ask questions, because this is all we are about. So thank you so much, and have a very good day. Hello everyone, welcome back to our YouTube channel. Today we'll be taking off substructure works. We have a diagram on the board, and this is a plan to the diagram that we'll be taking off. We are beginning a series where we shall do taking off for all elements of a building, starting from the substructure to up to the finishes. We are beginning this series today, and I hope that we shall be able to produce a video a day, so that we can be able to cover all elements of building works. More to that, we shall be able to do civil engineering takeoff, because this is the channel where we aim to help all our viewers and all our subscribers, together with our members, be able to understand the whole concept of coming up with a bill of quantities. We're coming up with a bill of quantities for the building works, and together with the civil works. So we will take you through the whole process from the introduction part, whereby we teach you how to use the dimension paper, the whole process of either taking off together with the abstracting, then the billing part. We will take you the whole process, and to begin it all, we are starting with the simplest and the most involving part of takeoff, which is the substructure works. So keep tuned. We always have our classes. We'll be having our classes every day. Most of the times we will even have the live classes, so that we can be able to interact with you, our viewers, so that you can be able to ask make questions, which I will answer to you directly. You realize that you have asked a lot of questions, especially on the comment section, but sometimes we get so busy, especially now that it is the construction industry. It involves a lot of work. So we're sorry for the questions that we have not been able to answer to, but now we will be able to continue answering more of your questions. We will do more of the video requests that you have already done, because we aim to have a class a day. Yes, so kindly tell us in the comment section whether at what time would it be really convenient to you, so that you can have the live class, and on what topics would you want us to cover for you, because we want to do the whole process of coming up with a bill of quantities for you. We are so grateful for all those who